Hi. So you just bought a MacBook and you want more. You can overclock a Mac? Yes, you can. It's easy? Yes, it is. So let's go through all the details and overclock our Mac. Okay, so let's start with a little bit of theory behind of this process, like overclocking, and everything what in it's in the background of uh, of overclocking, like thermodynamics, like electronics, and few other things. Yeah. Let's speak about overclocking. Overclocking is mean a basic clock looks like that. Overclocked is mean more clocks. More clocks, that means the processor can process more information at the same time. In a normal desktop PC, and laptop. Desktop PC, to overclock the PC, to overclock the processor, you have to raise the clock. That's the first thing. Clock. In order to raise the clock, you have to raise the core voltage. Raising the clock and raising the core voltage, this comes with a price hit. In order like the processor to cool down, you'll order the fan to spinning at full. Fans. On a laptop clock, we can't raise the clock. Like 90% of the laptops, you cannot increase the clock. 10% of the laptops, which are like high-end gaming laptops, yes, you can. V-Core, no, you can't. You can't increase the V-Core on most of the laptops. So in this case, how we can overclock our laptop? Let's have a look how a desktop PC processor is working. Yeah, we have the graphics. On the graphic, we have the frequency and we have the temperature. The base frequency, which is the idle one, idle, can be can have any value like up from 600, 700 megahertz up to like 2 gigahertz, 2.4 idle. The temperature, let's say here, 24 degrees. When you open an application, like a demanding application or like a web page or whatever, the processor will increase the clock. That's a normal clock. If the application is more demanding, the processor will start the turbo function, which is like a basic overclocked. So the frequency now from idle is go like up to like, let's say like 2.4 gigahertz. So that's our clock in this moment. That's the time. After a while, the temperature will increase. So the temperature will goes up, 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 and at some point, the processor will order the fans, let's say like 60 degrees. The fan will start spinning fast. On this moment, The temperature will maintain or go down, but the clock will be the same. On a laptop it's a little bit different. Have the same the time, and we have the temperature, have the clock. Let's say we have the temperature here and the clock, and you start some application, and the clock will goes up and more up, like to activate the turbo, and that's the max, yeah, 2.4 gigahertz, yeah. Let's say like this MacBook, yeah, 4 gigahertz turbo, and here we have like 2.8. Here is 2.8, here is 4 gigahertz. So here will be 4 gigahertz. That's the max frequency on the turbo mode. Then temperature will go quickly high. The fans will start spinning fast, probably at full here. Fans. Anyway, on the MacBook, the fans are very small, so they cannot take out all the heat. On most of the laptops, the fan cannot take out all the heat. So when the temperature will be here, which is around, let's say, 100 degrees, what will happen with the frequency? The frequency will goes down. In order to stop the heat, to lower the temperature. Yeah, and the temperature goes down a little bit. Yeah, and when the temperature goes down, the processor will start again to raise the clock, and the temperature goes up again, and the processor lower the clock, so the temperature goes down again, and so on. So basically, it's not fair. You are buying like a 4 gigahertz turbo mode, yeah, computer, and actually you cannot take advantage from 4 gigahertz clock, because it's always because of the heat. Always your clock will be lower. And when I say lower, yeah, don't get me wrong. Maybe my graphic is not right, but if here is 4 gigahertz, yeah, here is 4, yeah, and here it's without the turbo mode. Here will be like 2.8, yeah, 2.8. That's normal, not turbo mode, and it's not idle. It's idle. I think it's 700 and something megahertz. So when you have a normal mode 2.8, here we have turbo mode 4 gigahertz, but your clock will be lower, like 2.8. Will be under 2.8. Probably will be around 2.5 gigahertz. So it's not good. It's not even point to overclock this processor. It's not even point if he cannot cope with these values. So he cannot work even on the base clock 2.8 gigahertz. Always the temperature will goes the clock will goes under 2.8. So when you are doing like video editing, like 4K editing or gaming, yes, you can do gaming on a Mac. I'm doing gaming. That's the reason why I bought a Mac. I'm doing gaming, and I have Boot Camp installed with Windows, and when I need video editing, I just switch on the Mac, and I use the Final Cut Pro. So that's the thing with the laptop. This is most of the laptops, not only about the Mac. All the laptops they will react like in this way. They will lower the clock in order to keep the temperature low. So that's our problem. So I say that let's overclock the Mac. But for me, overclocking is mean to raise this lower frequency. You see this one? This is not good. I don't want to be here. I want to be here. I want to be like 4 gigahertz. So we will manage to raise this frequency. In order to raise this frequency, we have to think how we can do that. How we can do. We have a problem. The laptop has a problem. He cannot manage the heat. So let's think a little bit. The only way to raise the clock is to drag down the temperature. If I will keep the temperature here, yeah, my clock will be here. But how can I do that? The heatsink is small. The heatsink on the MacBook, it's just a piece of copper. It's a small one. And you know what? You will say now, yeah, but I will buy, I will buy the better Mac, the expensive one. Yeah, I know. I have the expensive one. The expensive one comes with the graphic chip. So we have AMD Radeon graphic chip. So actually, on this one, it's more worth like only with the Intel integrated graphics because you have two chips to cool down. So on this one, which I would say it's like a top the best Apple laptop because this 2015 model uh, is the last laptop who has like the F keys. When you play games, sometimes you use the F keys. On the new one, the 2016, are not anymore the F keys there. Or you can configure on the touch bar. So let's think, yeah. So if we go with the temperature down, we'll keep the clock up. So that's the achievement. How we can do that? How we can lower the temperature when we have this problem? We have a processor and we have a graphic chip. We have two chips to cool down, and obviously here, like even on 2.8, the fan will be spinning at full. The only way to cool down, you need bigger fans or bigger heatsink, and you cannot do it. It's no space. It's no space. I will show you how to do it. How to lower the temperature, yeah, in order to keep your clock up. And this is overclock. For me, this is overclocking. Maybe you'll say, this is not overclocking. Yeah, it is. If you do like how I sell like gaming and you know what, the processor and the graphic core comes like a package. So you have like around 60 watts processor and graphics on same heatsink, yeah, and working with same power. So you have 60 watts to use only for the processor or only for the graphics, or you can split the power between graphics and processor because they cannot manage to take out more heat like 60 watts. So you have 60 watts heat you can take out. You can get rid of 60 watts heat. So that's the thing. Let's check. Let's see. So let's check, yeah. So we have the MacBook. I choose the MacBook because it's slim enough. It's light. Probably it's up to 2 kilo. I can do gaming. I can do video editing, web browsing, whatever I want, and I like it. I think, from my opinion, the Apple hardware is the best. But we'll speak on the next video about this. So on this laptop, yeah, which is a metal case, yeah, aluminum metal case. So when you are using the laptop is cold. Even on the back, it's cold. So I was thinking on my head, why you are not using the metal like a heatsink? That's the main advantage on this laptop. It's all metal. On the other laptops, the plastic laptops, you can't do nothing. It's no place to put a heatsink. You cannot manage to take out more heat. But what about this one? It's full of metal. But Apple, how they think? I understand that. Yeah, they say, look, the man will use the laptop. Probably will do video editing or gaming on his lap. No one can. No one want to get burned by heat. So I understand this, but not me. Me. I want to take all the heat out. I want to keep the clock up. I want to take out from this laptop whatever is possible. I don't care about the heat. The laptop will be here anyway. And if I will put the laptop in my lap, I will not do like gaming or video editing. So that's the idea. We'll use the case like a heatsink. Let's check. This laptop is already modified. So we will check exactly what happened. And let's see. So what we have here, yeah? We have a 4-core processor and 8 cores because it's hyperthreading, has hyperthreading, and temperature on the processor is like 38 degrees. The core frequency 798, so it's around 800 megahertz. It's an idle mode. It's nothing. It's doing nothing because it's like 0% on all the cores. So let's start and stress the processor and also count the time. So use a counter to see when the processor will limit the frequency, when the processor will start kicking in. Let's check. Put my phone here. Have a clock and we'll start stressing the CPU same time. Yep. So we have around 5,200 points here. So it's like nearly 5,000. The CPU utilization is 100% on all the cores. The frequency is 3791, and the temperature goes up. You can see the temperature goes up. The package is 55 watts, but that's not important now. Important to see what's happened and how long will be this to kick in, and goes down probably around 6,000 and something. When the processor will lower the clock. So now it's around 80 degrees. The frequency on the processor is still full. So let's check how long will be. 88 degrees, goes quickly up, but it's still 7,200. So it's doing well. So let's check. Still 100%. The temperature is rising 90 degrees. So let's check. When he will lower the clock. The clock is same, 3791 megahertz. The processing power is the same, 7,200, around that. Now the fans start spinning fast. Yeah, and the processor lowered the clock, so we can stop. So it's around 2 minutes. You can see 2,793. So he lowered the clock. So check here, you see, 7,800. Even the power, the processing power goes down. The clock is around 90 degrees, 94, 100 degrees, and here is going down, even under like the base frequency, the 2.8, so it's going down to 2.7. So it's like 2 minutes. So that's what you have, 2 minutes. So it's still stressing, it goes down and it's kicking the frequency and the temperature goes low, and that will happen. And after that it's higher the clock and the temperature goes up again and again and again. You can see how it's changing the clock and it's changing the frequency basically. When changing the clock, the frequency gets changed. Obviously, when the frequency is low, the temperature goes down. You can see the fan are spinning at full. So exactly that happened on like any laptop, not only on the Mac, on any laptop. When the processor is too hot, he will lower the frequency, he will lower the clock. So it's like I bought a 4 gigahertz, like turbo mode 4 gigahertz laptop, and I use it on 2.7. It's depressing. So what we can do about that? Let's check. If I stop stressing the CPU, you'll see the temperature goes down quickly. The clock goes down to the idle mode. So let's check what will happen on a bigger laptop, on an Alienware, for example. Yeah, let's check together. This is my wife's computer. So let's check what is the story on like a proper gaming computer. So let's check. Same programs. You can see the temperature. Same a 4th generation processor. So let's check. Let's stress the CPU. So same thing, like 800 megahertz idle clock, and let me check. I think, yeah, 2.5 gigahertz like the normal clock, and I think in turbo mode is 3.5. But let's stress the CPU. You can see we have 6,300, 6,200 points. That means the processing power is lower, like the MacBook. It's like same generation, 2 years old. So all the clocks are loaded. We have 3.292 and the temperature 60 degrees, 62 degrees. Let's see how this will manage the heat. This big laptop, with big heat sinks, it's not a problem. It's no issue here. So the temperature is like around 670 degrees. 70, and yeah, it's just sitting there. and nothing happened. Everything is on full power. So that's the story with big heatsinks. So our problem is the heatsink. Bigger heatsink, no issue. The processor can be at full all the time. Yeah. Let's have a look at the heatsink. That's the heatsink. You can see like a big heatsink. Obviously, it's no problem here. So let's open the laptop and have a look. Let's check what's going on inside. Not everyone is looking for like big laptops or like desktops. I don't want a PC desktop. A PC desktop has like 3-4 fans there. I don't want noise. I want something small which I can carry around and have enough power, like play a game or edit a movie. So let's check inside. So don't do it if your MacBook is under warranty, or do it on your risk. Okay, so let's check. So what we saw on the phone and on the video, yeah, was 2 minutes after I connect the heatsinks with the back of the laptop. So yeah, this now is getting proper hot. But I don't care, I just want power. So let's check what we have here. Let's bring the camera closer. So it's all what I done. I extend the heatsink. Let's take everything out. And even on, yeah, because if I can manage to send the heat to anything, like anything, even on the back cover, I don't care, if it's getting hot. I just want to get rid of the heat. Here's the computer. He can't do it, He has 2 fans, like small fan, and a little bit of heat sinks. What's that? That's a heat sink? Look, so I have the processor here, graphic chip here, on same heat sink with 2 small heat sinks. Obviously, he cannot take the heat out. And I'm using, it's a special component, it's some thermal pads you can find on eBay. To buy these are cheap, probably like around £2 each, like a big 10 by 10. So I'm using over the processor and the graphic chip, So this will touch the back cover, and also I'm using for a few more things on the RAM, and I just use this to keep pressed to be sure it's not moving. And here we have the power supplies for the graphic chip. As I do I do gaming, sometimes I do gaming. And we have the south bridge here, over the south bridge, and we have a few more power supply like this big one, which is I think is for the V core. Yeah. So you can cool down the computer just sending the heat from the board to the back cover. And the back cover, yeah, will get hot, will get very hot. You can't even touch the back cover, but only on this area, only here. So here will be cold. On the other side, yeah, it will be cold, nothing changed. But here will be hot. So just think, yeah, if you stick like, even now it's fine. We will test without this. We'll take all out and we'll do another test to see which is the difference. To see how the computer managed to keep the higher clock and the lower the temperature. So we'll do another test without nothing here. But even now, you say it's nothing. It is. I have one more of this on the other side, behind of the processor. And also I replaced the thermal paste from the processor and the graphic chip with a liquid metal. It's a big difference between like normal thermal paste. Like I was using Arctic Silver 5, but it's a big difference with I think it's Cool Laboratory, the metal one. It's absolutely Cool Laboratory Pro, I think. It's unbelievable. It's a big difference. So let's check. Just like leave it like that and just check and count to see how quickly the processor will lower the frequency. So let's go again, Windows. Let's open the hardware monitor and check again. CPU Z. So we don't even start and we have like 50 degrees on the processor. Let's try to zoom in. Yeah, so we have like 50 degrees on the processor. Just let's start stressing and let's count. So the first one time was like 2 minutes. And now, yeah. Okay. So let's stress the CPU. Oh, reset. Okay. Again. So we start. The temperature goes up quickly. Yeah. It's 80. It's already 80. 90. and he's gone. He's gone. He start lowering the frequency. You can see. Yeah, he's gone after 49 seconds. So that's the difference. Yeah, he's gone. You can see he's lowering the frequency. Here you can see he's going down. Yeah, 49 seconds. So with the heat sinks, yeah, I have like full power for 2 minutes. Without, I have like 49 seconds, which is not enough. If you're doing like random things, yeah, it's okay. But for gaming and video editing, oh, see the fans are spinning at full. Yeah, he's dead. So now we got nothing. We not even 2.8 gig, like 2.7, 2. Yeah, around 2.7. Yeah, that's the thing. So let's put the heatsink back and speak about this. Yeah, so let's check. So again, on the MacBook design, the air comes from here, cool down the SSD drive, and come straight to the fan and cool the heatsink. Wow, proper hot. From my experience, yeah, I don't want to be nothing hot on any computer. And even on like normal laptops, like basic normal laptops, when I'm doing like graphic repair job, after I finish, I try to redirect the heat however is possible using this. This is some kind of gum who like send the heat, same like the metal thing. It's not like metal because it is a delay on it, but it's great redirecting the heat. It's absolutely fantastic. So if you want more, yeah, that's the thing. Just take out the heat. This cannot. No, this is for like for web browsing and just doing light things, not for heavy things like heavy gaming or heavy 4K editing. And it's easy, just you have to take down the screws and you put the heatsink over the processor and over the graphic chip, and this will touch the back. You can check. You can see it's not perfect. It's a little bit lifted. Doesn't mean it's fine. Doesn't mean it's okay. This way, I'm sure we'll touch the back. Always here on the South Bridge. I don't care. I just want to be the temperature to be low everywhere. Yeah, and I have these power supplies. Even here. I want to be cold. I don't want to be nothing hot here. And it's very easy to just do it like how we want. As to charging the battery. Charge the battery. Yeah, looks fine. And something more. You see these things here? You see? Here is space. You can go in here. Here is space. Here is space. Here the air comes out. And probably you don't know why. You just ask yourself why? They should redirect all the air through the heatsink, not from here. Why from here? But the point is, yeah, over the time, the heatsink will get full of dust. So there will be full of dust. Will be no air going out. So in that case, the air will comes here up and will cool down a little bit the heatsink. So that's the idea with this. But if you are a technical guy, yeah, and you are sure you will be cleaning the heatsink over the time, just cover these things. And I can use more. So that's the idea with this opening. When it's full of dust inside, yeah, the air will still cool down here from the top. I'll take apologize for my language. It's not my primary language, English. But hopefully you understand the idea. That's very easy to be cut down. Easy. Yeah. So everything is fine now. I can close both of my back of the Mac. And I can start doing some editing. And no more overclocking. Yeah, no normal overclocking, like raising the clock and CPU voltage over the time. The processor can die because it's stressful for the processor, for the motherboard, for everything. But doing this thing, like just get rid of the heat, so basically you lower the heat on all the system, like processor, on a graphic chip, you'll have a longer life. We all know what happened with the graphic chip when the laptop is overheating. It's not a theory, it's a fact. At some point the graphic chip will die. And you can do this on any laptop, not only on Mac. If you can higher the size of the heatsink, just do it. Nothing can go wrong. So these pads are not electrical conductive, so it's not a problem if they touch the board. Yeah. Now my laptop is like new and it's ready for gaming. So he's saying together, yeah, uh, how the heat can change the behavior of the computer. And regarding with redirecting the heat from the heatsink to the back of the computer on the Mac, you'll say it's out. Yeah, you are crazy, you know. You'll say you are crazy, you know. No one is doing like something like that. Yeah, but Apple they are doing on the 12-inch model. On 12-inch model, the MacBook, the processor, it's the heatsink of the processor is actually the laptop case, not the bottom, the top one. So it's a great idea just to redirect the heat on the case if you can. If you have like a plastic case, no, you can't. But even on that point, you can redirect the heat. I'm using like when I'm doing the graphics on the motherboard is the graphic chip. Over the graphic chip is the keyboard. The keyboard is metal. I'm using this kind of compound to redirect the heat from the back of the graphic chip to the back of the keyboard. So yeah, it's every time it's a good idea if you can get rid of the heat and you can keep the heat the temperature lower on your system, on your desktop or laptop, or yeah, that's a good idea. It's not a bad idea. So thank you for watching and have a nice evening. Bye.